Welcome to
FamilyMath120 Part 3.
Part 3. Now, you, at the end of our last movie, when I turned the camera off, you made a very interesting observation, okay, about how a new way you thought of to find the area of a circle. What was it?
Well, you chop it up into rectangles.
Go ahead, draw your picture.
Kind of like this.
Well, so it would be kind of like the sphere problem, except
It's with rectangles,
Okay,
not
that's
discs.
That's great. So we took our circle and we chopped it up into little like ice cream cone shapes, kind of, and then we rearranged them and added them together to form a rectangle.
yeah.
But you made a great observation that hey, this idea that we just used to find the volume of a sphere,
Then
we could have used that exact same idea to find the area of a circle.
Except
Yeah.
it's in 2D.
Right, except it's in 2D. That's the only difference. Shouldn't really be that much different, right?
Yeah.
So let's talk about that. Because it's a great observation. All right. Let's see what happens. We're going to do just like we did before, except we're going to now chop into rectangles. And this looks like exactly the same picture we had for the sphere, right? Except it's not three-dimensional, it's just two-dimensional.
Yeah.
So we have some height h, which is going to be 1 over n, just like we did before.
Yeah.
Okay? And then we just have to figure out the radius of
This circle.
of each disc, right? Because these are going to be rectangles.
Mm-hmm.
And I said the radius, but I meant the length here, this length here.
Yeah.
Because if this is x, and then this is going to be x, and the height's going to be h,
Yeah.
we're going to have a rectangle that's 2x long and h high, so we know the area. Just 2x times h, right?
Yeah.
Piece of cake. Probably step in just a little bit, or otherwise you're going to be off camera. So let's see. We have this. This is 1 for our circle.
Yeah.
This is some height h, and we know what h is for the ith disk. It's going to be I over n, just like before. So what does the Pythagorean theorem tell us that length is? So this is I over n. This is 1. What is this?
It's I over n squared plus
I over n squared
plus
whatever that is, x squared.
plus x squared
Equals 1.
1. So x squared equals 1 minus I squared over n squared, which is the same formula we had before,
yeah.
except the problem is we don't need x squared here. We need x. So what is x?
X is just the square root.
The square root of this. 1 minus I squared over n squared.
Well, luckily
Okay.
this is just this is I over n. Well, not really.
Why not really? Why am I making sad face when you do that?
It's negative I squared over n squared.
Nope. What does x equal?
X equals the square root of 1 minus I squared over n squared.
Okay. Can you do anything further with that?
Not right now.
No. The square root doesn't interfere with pluses and minuses. Can't say anything more than that. The square root of 3 squared plus 4 squared is not equal to what?
Not equal to 7.
It's not equal to 3 plus 4. 3 squared is?
It's not.
4 squared is?
It's 16.
So 9 plus 16 is?
It's 25.
The square root of 25 is?
5.
5.
Not?
Not.
Not 7.
No.
Okay? Square roots can't come inside when there's pluses. Got it?
Yeah,
Will you ever make that mistake again?
maybe.
Yeah. Okay, so we have this complicated formula for x. Okay, so now disk 1, or rectangle 1, has height 1 over n times distance of 2x, remember 2x across?
Yeah.
So I'll just say times 2 times the square root of 1 minus 1 over n squared, or 1 squared over n squared.
Yeah.
This 2 is 1 over n, and then the length is 2 times the square root of 1 minus 4 over n squared. Dot, dot, dot. Okay? So unlike in our last video with the sphere where we were adding up nice things that didn't have square roots and we were just adding up 1 over n's and then also squares,
Yeah.
here we have square roots to add up. And do square roots like addition?
No.
No. There's no real nice way to do this, unfortunately. So we have to figure out how to add up. Well, each one of them has a 2 and a 1 over n, right?
Yeah.
So let's factor that out. 2 over n times the square root of 1 minus 1 over n squared plus the square root of 1 minus 4 over n squared plus dot, 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 the square root of 1 minus n squared over n squared. Okay, so we have this sum here. Do you have any idea how you add up this sum?
I don't think so.
Do you have any idea how you add up this
No.
sum? The only thing we can say is this sum will add up to be the top half of our circle,
And then we're gonna.
which is, in the area of the circle, is pi, right? Pi times 1 squared. So we have some weird formula that says pi over 2 equals this.
Whoa.
Because we know the area of the circle, and we know this is sums to be the top of the circle, but we don't know how to do this sum. But we've just discovered an amazing mathematical formula that pi relates to these square roots somehow.
Whoa.
Okay? So why don't we at least go check and see on the computer if this formula ends up being sort of true. If we let n get really large, do we get pi over 2 for this sum? Or let's multiply the whole thing by 2 actually and say pi equals 4 over n times this.
Alright.
Okay?
Okay.
Alright, and to do that we're going to use Wolfram Alpha.
Awesome.
Okay?
go.
You like using Wolfram Alpha?
Yeah.
Me too.
Let's go.
Alright, here we go. Okay, so here we are to use Wolfram Alpha to talk about our formula that we got. And you see our formula here. It says Wolfram Alpha, we tell it to sum. And in this case I used 10 rectangles. I wish we had a picture, but I don't.
Yeah.
So, but our formula was 4 over 10 times the square root of 1 minus I squared over 10 squared,
Which is 100.
which is 100, and we sum from 1 to 10. Then the mathematical symbol for sum is this Greek letter sigma.
It's S, which is.
S for sum. So you can see it says 4 over 10, and it goes from 1 to 10. 4 over 10 times the square root of 1 minus I squared over 10 squared, and this equals about 2.9. Which is not super far away from pi,
No, it's
but it's also not super close to pi. But on the other hand, we only use 10 rectangles.
Let's use more.
Okay.
Let's try.
What do you want to do for more?
Let's try maybe 100.
Okay, so we got it here. We say 4 over 100
Yep.
times, do you know what 100 squared is?
I think it's 10,000.
10,000. Good job. Sum from 1 to 100. Let's see if we get closer.
Nice.
Okay, Wolfram Alpha is crunching, 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 and hey, 3.12.
We got something, but we're
That's
getting.
really close, right?
Yeah.
Okay, what do you want to try next?
Let's try
1,000.
1,000.
All right, 1,000. So 4 over 1,000. You got to add 2 more zeros because 1,000 squared is
A million.
a million. We got to sum from 1 to 1,000.
Nice. And then.
3.139.
Wow.
Close.
Getting close.
Getting close. You want to try 10,000?
Sure.
Yeah.
All right, let's try 10,000.
Alpha.
10,000 squared. We got to do 2 more zeros and sum up to 10,000, and this will be the last one we do. I don't know if Wolfram Alpha can do this or not. Well, it's taking a long time. It's a complicated calculation.
Computing. There.
3.141.
3.1413, getting really close.
Yeah. Whoa.
Wow. All right, guys. So we at least seem to think that our formula works,
Yeah.
right, and converges to pi.
Nice.
And it's an interesting demonstration that one way of chopping up the circle into those little ice cream cone shapes
Yeah.
produced an easy way to see that the area was pi r squared.
Yeah.
The way we used for the sphere, which was pretty easy for the sphere,
Yeah, but for the circle, it was
Not easy.
it didn't work at all. Well, I'm sorry, it did work, but it just produced a really complicated way that would have been very hard to figure out without a little help from Wolfram Alpha.
Yeah.
But we did find a really cool mathematical formula with square roots that seems to converge to pi. So that was cool at least,
Yeah.
right?
Yeah.
All right. Do you think anyone else has ever found that formula before?
Maybe.
Maybe. Who knows? All right. Good job today, guys. That was a fun day.